Hello and welcome to Azure Back to School. Today in our session we are going to cover how to build everything on serverless. So nowadays you could see a lot of the organizations are moving to the cloud, and to be specific they are approaching the serverless model. So why do they even choose this serverless model? So to answer to that question, there are actually many benefits with the serverless model, and we are going to cover all of the benefits with the different use cases in our today's session. So myself, Divakar Kumar, I work as a senior software engineer at H&M, and without any delay, let's move on to the module. There are around 5 modules that we are going to cover in this session. In the first module, we are going to see how to develop an Azure function, and also how to deploy your application into an Azure static web app. In the next module, we are going to cover how to orchestrate different workflows with your application with the help of Azure Logic Apps. In the next module, we are going to see about serverless messaging, what are the different capabilities of an event grid, and how to deploy it in your Azure portal. And in the next module, we are going to see how to enhance your static web app with the help of Azure Cognitive Service. We are going to also cover Azure Web App in this particular module. And in the next module, we are going to see about Azure Cosmos DB and how to deploy it in a serverless mode. Before getting into these individual modules, let me introduce you to the tool that I have developed for explaining these concepts. So this is the high level architecture of our website. In the center portion, you could see there is an Azure static web app with which I am hosting both the front end and the back end. For the front end, I'm going to use Angular framework, and for the back end, we are going to use Azure functions. And there is other service like Azure Event Grid, which acts as our publish subscribe channel. Whatever the events that you are going to publish from your backend will be passing through this channel, and it will be reaching all the subscribers that are interested in these events. Right now we do have only one subscriber, that is going to be the Azure Logic Apps. And there are other supporting services like Azure Cosmos DB, which acts as our persistent layer. And there is another service, Azure Cognitive Service, with which we will be able to detect our voice and transcribe the voice into different languages that we will see in detail when we are showing the demo. And there is one more service that we have, Azure Web App CLI. So this acts as a WebSocket service channel. So whenever a message is published or broadcasted from the front end, will be reaching through this service channel, and it will be passed on to the upstream events. Upstream events is nothing but a Web App CLI trigger. So inside this we do have a lot of business use cases, and based on that you will be broadcasting the message back to the front end client with the help of WebSockets. So this is the overall architecture, and in the rightmost corner you could see what are the tools that I have used for developing this application. For the front end I have used Visual Studio Code, and for the back end I have used Visual Studio. And there is a GitHub action that will be automatically generated. There will be a workflow generated in your repository whenever you are deploying your application into Azure Static Web App. So we will be seeing these in details when we are covering the Azure Static Web App module. So let's see how the website looks like. So this is the website that I was talking about. So in the landing page you will be able to see all the sessions that you have created or other authors created, and you will be able to join the particular session or enter into your own created sessions. In the below section you could see there are a list of blogs that I have attached to this page, and you can traverse through those each blogs by clicking on the link, and you will be directly redirected to the specific blog of that particular page. You will be able to create a session on clicking on that button, and you will be able to provide the details of the session title, description and the date, and also you will be able to choose whether it should be a public session or a private session. And based on this we do have different use cases in our Azure Logic app. So once you create those sessions, you will be able to see those in the live sessions. And what I'm going to do is I'm going to enter into a particular session that I have created earlier, and you will be prompted with the two options, one to start the session and one to stop the session. So once you start the session, my browser is going to detect my voice using the plugin, and also behind the scenes what is going to happen is whatever the languages that I loaded in the drop down, there are different languages that I loaded in this dropdown, and my voice is gonna be transcribed into these individual languages, and it is gonna be published through all the clients that are subscribed to these WebSockets. So if I gonna connect into another browser, say suppose I'm gonna open a browser in the incognito mode, and in that browser I'm gonna join the same session, and I'm gonna listen to that particular session. So let's see what's gonna happen. So in this incognito mode, I logged in through a different credential, and now I'm gonna join the same session that we are started earlier. So once I join the session, I'm gonna listen to the session. So what is gonna happen is, whatever I speak in this browser is gonna be published as a broadcast to all the clients that are gonna join in this particular session. This is achieved through the WebSockets that we will be covering in detail when we are going to see the Web App Sub and the Azure Cognitive Service. And there is one more thing in this particular transcription. So if you change the language, right, so now you will be able to see whatever I speak in English in this browser will be translated into Tamil in the other browser that you could see here. So so this happens. This is happening with the help of Azure Web App Sub in the backend, and also there is an upstream events that we have created with the help of Azure Functions, and along with this, the entire communication happens in the WebSocket channel. So now let's get into these individual modules. In the first module, we are going to see serverless compute. In this, we are going to cover why do we need Azure Static Web App in the first place, where we will be comparing the traditional web application and the static web application. And in the next stage, we will see how to set up a local development environment with which you will be able to run both the API and the app in your local setup. And in the next module, like we will see how to establish an authentication and authorization flow with the help of Azure Static Web App. And in the final stage, we will see a demo on this one, like how to deploy your application into Azure Static Web App. So in the traditional web application, consider there is a browser. It is going to send a request to the server. So once the request is reaching the server, it is going to be sending the information back to the web application that is going to actually serve this particular request. So in the web application, you will be fetching the data from the database if in case you want to serve any dynamic contents. So once you fetch the data from the database, it will be again used to create an HTML, dynamic HTML, which will be sent back to the browser. So this is what happens in the traditional web application scenario. Considering the static web application scenario, so here the browser is going to send a request to the server, and once the server is once the request is reaching the server, so there is going to be a static assets that is going to lie in this server itself, and you are going to serve back this request with those static assets back to the browser. And in the browser, if in case you want any dynamic contents to be published, so you do have a JavaScript plugin with the browser, and you are going to make a REST API calls with which you can show the dynamic contents in your page. So now you could see in case of static web application, the request is going to be served faster rather than in the traditional web application. So now let's see why do we need Azure Static Web App. So along with the benefits of the static web application, we do get other benefits like globally distributed hosting. You don't need to configure any CDN with your application. Once you deploy your application into Azure Static Web App, the global distribution will be taken care by the Microsoft, and you will be getting support for integrated API with which you will be able to host an Azure functions along with your front-end client. And also you do have an extensive support for the GitHub Actions, and also there is a support for Azure DevOps as well, with which you will be able to establish the CI/CD pipeline. And also you do have the support for the custom domains creation and also you will be getting a free SSL certificate for those domains. And there is an extensive support for the Visual Studio Code IDE, and also you will be able to work with this in the local environment using the static Web App CLI as well. And the next benefit is the staging environments. So whenever you create a pull request based on your feature branch, right? So automatically behind the scenes, there is going to be a staging environment that is going to created by the Microsoft for you, where you can test the functionality, and once you approve the pull request, this staging environment gets deleted automatically behind the scenes. And also there is an extensive support for the authentication, authorization, and also the custom routes as well. And finally, this is going to be an enterprise ready application. So now let's see how to set up with your local development. In order to set this up with your local development, you do need to have a static Web App CLI. So let's see how this works. So consider this is going to be your CLI, and it is going to emulate all the functionalities that we are going to have in the live future. So right from serving the static app assets, it will be able to serve the static assets using a proxy, and also it is going to proxy your API requests through the Azure Function Core tools, and also you will be able to emulate authentication and authorization as well. And finally, you will be able to emulate the configurations and also the routing and other configuration along with this Azure Static Web App. So now let's see how the authentication and authorization flow looks like in our Azure Park. So this is going to be the flow that I have established in the Azure Park. So there are three providers that has been provided by the Azure Static Web App as an out-of-box feature for our authentication providers. One is Microsoft Active Directory, then the GitHub, and then the Twitter. So with the help of these providers, you will be able to establish the authentication and authorization support. So once you authenticate through these providers, you will be getting hold of this particular JSON, with which you will be able to authorize an particular user, whether he is an authenticated one or unauthorized one. So in order to achieve it, you might need to have the framework specific way to handle these validation logics. In our Angular SPA application, we do have the auth cards which is going to validate this, and there is a specific endpoint which will be returning back this JSON. It is /auth/me that we will see when we are showing the demo. So once you reach into that particular API request, you will be returned back with this particular JSON, with which you can validate the particular request. And this is going to be the same procedure that you will be following in the Azure Functions app as well. But the only difference is you don't need to make any explicit call to this particular endpoint. In the Azure Static Web App, behind the scenes, there is going to be a middleware. It is going to bind a header XMS client principal, which will be holding this particular JSON value, and that helps you to authorize your request in your Azure Functions app. So now let's get into the demo to see how to deploy an application into your Azure Static Web App. For this demo, I'm going to use Visual Studio Code as my IDE, and I'm going to use a template that is same as this AZ Park template. Let me show you the template. So this is the template that I'm going to use, and it is a free template that has been provided by Dashboard Pack. I just poked it from this repository, and I'm going to clone this particular repository into my local environment. So let me clone it. Let me provide a path for this one. Meanwhile, it is cloning. Let me show you the extensions that you might need for this deployment purpose. One is static web app. So make sure you are installing this extensions along with Azure Functions. So these two extensions are a required one to get this deployed. Once you have installed these two extensions, you will be able to find this icon. Under this icon, you can find the static web app section. So click on this add icon, and it will list down all the subscriptions that you have with this particular tenant. So right now I have logged in through this credential, and it is going to pick up all the subscriptions under this particular tenant. I'm going to use the Azure 360 subscription. I'm going to provide a name for this one. Azure School. And these are the regions that are currently available for your deployment in the Azure Static Web App. I'm going to choose Central US. And for the framework, we might need to choose the Angular framework. The template is based out of the Angular template. And for the location, it is same as our root location, so I'm gonna keep this as a default one. And for the project name, let me copy it from the name here. So this is the folder path where it will generate the output files. So once you run the npm run build, you will be getting to know that there will be a folder will be created with the same format. So you need to provide that in this deployment activity, so that based out of this there will be an workflow file that will be created by the Microsoft for us. We don't need to configure anything or write our own workflow file for this one. So once this is completed, you will be able to see there is a git pull happening, because right now the workflow file is already created, and you could see that in the GitHub as well. And it actually triggers the CI/CD pipeline for you. So if I go to the code, the workfile here, like it will be created by the Microsoft, and you could see all the configuration that I have provided in the deployment activity will be pre-populated here. So once the build process is completed, you will be able to see it is actually deployed into your Azure Static Web App. So let's look at the portal. So in the portal, you can find the static web app by clicking on this icon and typing static web app. So you will be able to get into the list of static web apps that you have already created. This one is to create a particular static web app from the portal. Right now we have done that through the Visual Studio Code. So I'm just gonna go to the static web app to see the list of static web apps that we have. And here is the one that we created recently. So what is going to happen is there are currently two environments that will be available. One is the production environment and another is the staging environment. So right now you can see from the master branch there is a deployment activity that is ongoing, and the staging process will be kicked off only when you create any pull requests from your repository. And in order to test that, you will be able to see a new environment that has been created by Azure Static Web App. And once that pull request is completed, you will be able to see that that will be deleted from your portal automatically. So once the deployment is done, you will be able to see the status is completed. So before that, let's see the custom domain. So here is where you will be able to configure your own custom domain from your domain provider, and you can configure it. And once you configure it, you will be able to get a free SSL out of it. Let's see the GitHub action. So now the build is still running. So let's wait for a couple of minutes. So I think that is completed. So now you could see the template has been deployed into our site. So now we have completed deploying the front-end application into our Azure Static Web App. So the next step is to deploy our API as well to this Azure Static Web App. So in order to do that, let me rearrange these folders so that we will be having two folders, one for the backend and one for the API. And I'm gonna move all the front-end contents to the app folder. So now we have moved all the front-end sources to the app folder, and now let's create an Azure function. So in order to do that, click on this Azure icon and click on the create new project icon. So now it will ask for the project location. Choose the API folder. So I'm going to use C# as my language for the development purpose. And you will be able to have two options. One, to run this in a isolated version, that is .NET 5 version, and also you can do it in the in-process version as well, .NET Core. So I'm going to go with the in-process one. So for the template, I'm going to choose HTTP trigger with OpenAPI. I'm just going to leave this same. Let me reclaim this. Anonymous. So meanwhile, if it is creating the project, let's make sure the workflow is changed a little bit, so that now we need to point it to the app folder for the front-end client, and for the API location, it is already pointing to the API folder, so there is no need to change this particular configuration. So now what happens is, once we push these changes into the GitHub, right? So now along with the front-end client, you will be able to see there is an Azure function as well deploying in the Azure Static Web App. So I think now Azure function, the project has been created. So now we could see there is an HTTP trigger along with the OpenAPI support as well. Let's deploy this and see how it is working behind the scenes. So now we are committing it to the master branch. But if you want to test in some other branch and you want to create a pull request, right? So you can do that, and you will be able to see a staging environment that is created automatically for you. So now I have pushed the changes. So let's see if the actions has been triggered. So now it is running my build. So now we could see the deployment is done, and if I refresh this, we will be able to see the API is also deployed. So now we could see the API is deployed along with our front-end client. So let's get into the site. So now we could see the HTTP trigger is function is executed successfully. So this is how you will be able to deploy your application along with the backend API. In the next module, we are going to see how to create serverless workflow orchestration. So in this module, we are going to see a workflow that we have implemented in the Azure Park, and also we will cover how to create event grid topics and the subscriptions. So when you consider logic app workflow, there are many benefits with it. The main benefits are, you will be able to create a business process and the workflow visually. All you need to do is just drag and have the workflow based on certain connectors, and you don't need to implement this in the backend code. So the development process will be much faster when you are going with this approach. And when it comes to the integration capabilities, they do have extensive support for the web application, mobile application, and as well the app backend. And when it comes to the cost, it is much cheaper and effective. For the first 4000 actions, you don't need to pay anything, and for the next set of the actions, you will be paying only much minimal when compared to other services. So it is a cost effective one, and it is also a scalable and a lightweight one. So this is the workflow that we have implemented in our website. The main player here is the event grid. All the events are published through this channel, and based on this event, we are gonna have 4 different use cases for our website. The first use case is whenever user logged into the website, so we are gonna pick a mail address from the event, and we are gonna send an invitation mail back to that user. And along with this, we are gonna update the Cosmos DB as well. This is to validate whether the user is already logged in or not for the next time. And when you consider the next use case, we have already seen the website, right? Like in the website, you will be able to create the session basically based out of 2 categories. One is the public category, and the other one is the private category. In the public category, you don't need to have any workflow, but in the private category, whenever a user is requesting for a session, right, you need to have an approval flow of mechanism, so that the author of this particular session will be either approving or rejecting the particular request. So based on these 2 actions, there are 2 events that are going to be emitted. So one is the approval event, and other one is the rejection event. So for the approval event, if the author approves the particular join request, we will be sending an approval mail back to the sender who requested for this session, and he will be able to join the particular session using the link that we have sent in the mail. In the rejection mail, we will be sending out a rejected mail notification to the respective user who raised this join request. So we are going to see the serverless messaging as well, and at the end of these both modules, we are going to see how to create the logic app and as well the event grid modules. So when it comes to serverless messaging, there are 2 ways you can categorize these messages. One is event and other one is the message. When it comes to event, there are 2 services that you can think about. If it is going to be a discrete events, you can approach this event grid module, and if it is going to be a series of events, you can consider this event hub service that is being provided by Azure. And when it is something that you are handling with messages, then you can think about this service bus as your suitable service to handle that particular message. So when it comes to the event grids, there are 2 things. One is the source from where your event is going to generate, and other one is the handlers that is going to handle these events. So these are the current sources that are provided by the event grid. These are the current handlers that we have with respect to the event grid, and currently we are going to see how to have the logic app as a subscriber for this event grid. Whenever you create an event grid, you can do that in 2 ways. One is to create the event grid based out of a grid event model. That is the default way of doing it, but there is another way where you can define the model to be a cloud event. So this event model is nothing but a specification that is recently adopted by everyone, which is formed as an uniform way or a standard way for routing and handling the events. And even if you see the internal communications or internal events that has been triggered from the Azure platform, so those are based out of this cloud event model. So moving forward, I believe we don't even see the grid event model in the coming days. So now let's see a demo on how to create a logic app workflow along with an event grid topic and the subscription. So now we are in the Azure portal. Let's create a logic app workflow by clicking on this icon. and in the search box type logic app. You will be able to find the logic app instance, and you will be able to create it. So as a first step, you need to provide a resource group. Let me create a new resource group. So once that is done, you will be able to select two instance type, that is going to be consumption, and the next one is the standard. So we are going to create a consumption model, and you need to provide a logic app name. So once that is done, you need to provide a region where this should be deployed, and I'm going to leave other things as a default one. So I'm gonna click on the create button. So this is gonna take a couple of minutes for the deployment one, and once that is done, you will be able to see this go to resource button enabled. So now it redirects us to the designer portal, where you will be able to create the workflow. For the first step, we are going to need this connector, which helps us in generating an HTTP post URL, which we will be using as an webhook to connect it to an event grid topic. So for the request body, we are going to use the same JSON schema that we used for the AC bar. I have copied that JSON here. Just going to paste it here. So once this is done, I'm just going to save this. So once we are saving this workflow, you will be able to see there is an URL that has been generated. So this URL can be used as an webhook in our event grid subscriptions. So now let's create an event grid topic. It is going to be a same process again. We are just going to search for event grid topic here. I am going to create a new event grid topic. So I'm going to choose the same resource group that we used earlier. Provide a name for it. And we should be providing a region for this as well. So in the next tab, you will be able to see there are three options that is provided for the event schema. The default one is the event grid schema, and the schema that we are going to follow in this demo is the cloud event schema. So make sure you are choosing this cloud event schema model, and I'm going to leave other things as a default one. I'm just going to create it. So this is going to take a couple of minutes, and once that is done, you will be able to create an subscriber for this event grid topic. So let's wait for a couple of minutes. So now this is deployed. So let's get to the resource. So in order to create a subscription, just click on this create one subscription. Provide a name for the subscription, and make sure the schema is representing the cloud event schema model. And for the endpoint type, we should be choosing the webhook. So in the endpoint URL, we should be providing the endpoint URL that we created earlier in the logic app. So let me copy that from the logic app. So I'm going to copy this URL and I'm going to paste it here. So once the deployment is done, now you could see the subscriber is linked to this event grid topic, where we have mapped it to the Azure Logic App endpoint that we have created in the previous step. So this is how you will be able to bind a event grid topic and subscription, and as well you will be able to create a Logic App workflow based on it. So now let's see how it is already done in our Azure Park website. So if you see the designer, you could see there are 4 events that we are interested in. This is the same event that we seen earlier in the PPT. Let me walk you through the invitation mail event. So whenever a user is logged in, it is going to trigger this particular event type, and if it is going to be same as this event type, then what I'm going to do is I'm going to pass the data, and from the data I'm going to pick up from and to mail address with which I will be able to send an invitation mail. So in the to mail address, it will be the user who logged in, and as a parallel branch we are going to update a collection where I'm going to store who are all the users that are already invited, which will be basically used as a prerequisites whenever I'm going to validate whether this user is already invited or not. So this is how the workflow has been created for the AZ Park site. And let me walk you through the event grid topic that I had for the AZ Park. So now we are inside the event grid topic for our Azure Park website. So here I do have only one subscriber, that is going to be the Logic app, where we are going to expose one URL that acts as a webhook for us, so that whatever the events that is published into this event grid topic will be consumed by this Logic app workflow. In the next module, we are going to see how to enhance our application using Azure Cognitive Service and Azure Web App CLI. So to start with, let's see how the Web App CLI workflow takes place. Before that, the Web App CLI works on the basis of WebSocket connections, as similar to our SignalR. But in the SignalR, we do have the capability to change the fallback mechanism to an long polling or server side events. But in the Web App CLI, we do have only one option, that is going to be the raw WebSocket, and you don't need to configure any specific client in your front-end applications. It works based on the WebSocket client that is integrated by most of the browsers today. So if you have the WebSocket, you will be able to use this Web App CLI service. The workflow starts from the client. The client sends an handshake to the WebSocket service, that is going to be our Web App CLI service. And once this handshake is happening, the service in turn will send a connect event through the upstream events. The upstream events are nothing but the event handler for our client, which can be Azure functions as well. In our case, in the Azure Park, we are going to use Web App CLI as a trigger. And once the connect event is established, you will be able to send the message back and forth client, and the message will be passing through the service. It reaches the hub, a specific hub or a specific group of connections, and then it will reach the upstream events. So once it reaches the upstream events, based on the business use case, you will be performing some logic around it, and you will be sending back to the service with the help of output bindings, and in turn it will be published back to the client. This is the overall workflow that we have in the Azure Park website that we have seen in the demo. First, the client will be communicating with the Azure functions in order to get the client connection URL back to the client. So once this client connection is sent back to the client, it basically contains the WebSocket URL with which you will be able to communicate through the Web App CLI service. So this is the process that takes place in the first and the second request. So in the third and the fourth, what happens is client will be publishing some messages to the Web App service, and in turn the service will be reaching out to the upstream events that we have in the Azure Functions app through the input binding of the Web App connection. So once the message is handled, the message will be published back to the service using the output binding, and it will be reaching to the client. So this is how the overall WebSocket connections and two-way communication is happening in our Azure Park. So now let's see a demo on it, on how to create a Web App service and also how to configure the speech service in our Azure Community Service. So before creating those resources in the Azure portal, let's see how this Azure Web App is actually implemented in the code. So this is the folder structure that we have for our AZ Park. You could see this is the Web App sub trigger that we have for our application, and I do have two files. All the Web App sub trigger input bindings will be categorized under this file, and the first and the second communication that we seen in the PPT is nothing but this particular endpoint, where it is actually an HTTP trigger which acts as an input binding, and for the output binding we are using the Web App sub connection. So this actually sends the connection details which contains the URL for the WebSocket. So based on this URL, you will be able to connect through the Web App service and establish an handshake between the client and the service. So once that is done, you will be able to get hold of these events. So there are two system events that I am currently handling in the functions trigger. So one is the connect and the other one is the connected event, and there is an user event as well, which is the join session, which has Web App sub as an output binding, and I'm gonna pass this message to a specific hub under session. So this is how the Web App sub output binding works. So now let's see how to create that Azure Functions Web App sub trigger in your portal. So to demo this, I have already created a Web App sub function which I am using for the Azure Park website. So let me give an overview about this one. And it is same as you create an Azure functions. The only difference is once you deploy your Web App sub trigger into this actual Azure functions, what happens is there is going to be a key that is going to generate behind the scenes, and you might need this specific Web App sub extensions to be added into your Web App sub service. So let me go to the Web App sub service. So this is the service that I was talking about. So here you need to go to the settings where you will be actually registering the webhook. It is the same concept that we did earlier for the event grid. So here you need to provide the functions function app URL along with the code that we seen earlier. So now let's see how to create an Web App sub service. I'm not gonna demo how to create an Azure function. It is as we did earlier in the Visual Studio Code. The only difference is you will be getting the code once you deploy your application into your Azure functions. So in order to create the Web App sub service, click on this create a resource icon and search for Web App sub. So this service is currently in the public preview stage and it is not enterprise ready. So I'm just gonna map it to a resource group that we had earlier, and you just need to provide a name to this pub sub service, and you need to provide a region. So currently there are only few regions available. As I mentioned earlier, this is still in a preview stage, and you could see there are two pricing tiers that you could choose from, either a free or standard. Let me choose the free one, and I'm gonna have the remaining parameters as a default one, and just gonna create it. So once I click on create, you will be able to see a Web App service is going to be created behind the scenes. So now the deployment is completed. So let me go to the resource. So the main thing that you might need from this Web App service is the primary key to establish the communication. And in the settings tab, make sure you are adding a hub name for your application, and you are providing an webhook URL in this URL template. So this is basically the Azure Functions URL along with the code that we have seen earlier, and just click on the save. So the next thing that I want to show you is how to create an speech service for your application. So in order to do that, just click on the create resource and search for speech service. Click on create. So you just need to provide a name for this, and provide a subscription, location, and the pricing tier. Basically you will be having two pricing tiers, a free and a standard. Free should be working out, and a resource group to maintain this particular resource. Once that is done, you will be able to see something similar to this speech service, where you might be needing this keys and the endpoints, which you will be configuring in the front end client, with which you will be able to detect your voice and as well translate your voice into different languages. In our last module, let's see how to create a database out of a serverless mode. In order to do that, let's understand various concepts that we have in the Azure Cosmos DB. So before getting into the request unit, you need to understand what is the meaning of latency and the throughput. So the latency is nothing but how long user is waiting for a particular request, and throughput means how many requests can be served within a specific period of time. Cosmos DB ensures how much workload your database can handle with the help of request units provision. And you can do this in three modes. You can either do that in the manual mode, or in the autoscale mode, or in the serverless mode. So let's see how the pricing looks like in different modes. In this table you could see the pricings of different modes that we have seen earlier. In the manual mode, consider you are charging for the 100 request units per second, where you will be ending up paying only $5, whereas in the autoscale mode you will be ending up paying $8, because the amount they charge for autoscale mode is slightly higher than the manual mode. If you consider the serverless mode, for the first 1 million request units per second, you will be paying only $0.25. So that is the advantage that you will be getting out of the serverless. But it is not a thumb rule like we should be always preferring the serverless mode, because you will be ending up paying more in the serverless mode rather than the manual provision throughput. So now let's see how to transform your queries to read points. The read points are nothing but whenever you are configuring a Cosmos DB, you will be mentioning the partition key for a particular collection. So make sure you are choosing this partition key wisely, so that if you make use of this partition key along with the ID in your query, it will be much faster, and you will be ending up using much lesser RUs when compared to the using the traditional query that we can see here. So in the first query, you will be ending up using 3 RUs, whereas in the second query, if you are querying based on the ID and the partition key, you will be ending up only using 1 RU, that is basically picking up the particular document from the collection, which equates to an RU cost of savings 66%. Now let's get into the demo to see how to create this Cosmos DB in a serverless mode. So now we are in the Azure portal. Let's click on this create resource button and search for Cosmos DB. So in the Cosmos DB, you will be able to see list of APIs that are available. For the demo purpose, I am going to use SQL API. Here the resource group, you need to choose the same as we did earlier. and you just need to provide a name for the account and a region for the deployment purpose. The only change is in the capacity mode. So here you should be choosing the serverless if you want to create the database in the serverless mode, where you won't be configuring any of the throughputs manually or in the auto scale mode, and then just click on create button. So once it is created, you will be able to see a Cosmos DB has been created, and you can make use of it in the serverless mode. So now we came to the end of the session. Now we could see what are the different advantages that we have with respect to the serverless architecture. If in case you want to clarify any of the doubts, you can reach out to me on the links that I mentioned in the first slide. Thank you.